about Snell's law in corn oil. All right, so light can go through different materials, and we have ratios that explain how exactly the light will bend, going from something like air into a liquid or any transparent material such as diamond. Okay, so I'm going to show you how to do homework, and hopefully you've done the Ed puzzle before. All right, so this is the first problem on the homework page, and I'm going to give you a quick recap of Snell's law. It relates to different materials. Now, in our case, we have, hi, physics students. All right, so we have light indicated by this light ray. This is the incident light ray, and it's measured coming in from the normal. Hopefully you saw that that's the normal. It's a perpendicular line. All right, it comes from air. It goes into corn oil, which has more molecules, so it's denser, and it slows down. All right, so that's the angle of we're trying to measure, the angle of refraction. Okay, so refraction is a bending of light. So here we do, we're going to plug in Snell's law, and it's like magic. I've already written it out. All right, so here's Snell's law as it's shown in your reference table. So I turn to the reference table, and there's your Snell's law. And if you have this side with I's, that means incident, the incoming light ray. And if you have this side with R's, that means the reflected light ray. That's all that means. Okay. So let's see if you guys can see this okay. All right. So how would you put all this information in? If you're looking at the first homework problem, you have air and corn oil. So there's your ends. And I'm going to give you theta 1 or theta I, depending on what formula you use. And in our case, I'm just going to randomly say it's 30 degrees. So 1 sine 30 equals 1.47 sine theta 2. And that I got off the physics reference table. Okay, now by magic, I put this into my calculator. Sine 30 is 0.5 times 1, still 0.5. I just carried this down. And I carried the sine theta 2. And that's what we're trying to find. We're trying to find that angle. All right, so how do we get rid of what we're trying to find that angle? We had to get rid of that number. So we divide through by both sides by 1.47. And then we're going to plug this into the calculator. The 1.47 cancels out. So now plug this into the calculator and you get 0.34. And what's left here is sine theta 2. Now, how do you get rid of sine theta? And this is a little tricky if you haven't had trig. You're going to have to use something called the inverse sine button. You want to use that button right here. It's also known as the arc sine. Okay, so what I do is I put inverse sine on both sides of the equation. Most people skip this step over here, but I just wanted to be clear. The arc sine or the inverse sine of sine theta is theta. So all this equals that number. And then you're going to plug this number into your calculator. So when you use your notes, all right, so this actually has a different decimal number, but if you plug this in, you hit this number first, then 0.34. And you will get this number as an output, 19.88, but I didn't round, but you could guess it's 19.9 degrees theta 2. Now, what does this actually mean? That means in the original example, one single light ray will come in to a surface, such as corn oil. It could be any type of material. It's more dense. Now, normally you would think it'd go like straight here, but we kind of know that light bends. So how does it bend? We've now related it. We found theta 2. So it bends towards this normal line. So that's when they say it bends towards normal. Now, if it's a lesser dense, it would bend more this way. All right, so what is this? What is the angle we just found? This is the angle we just found. So we now can say, I got to write upside down, theta 2 is 19.8 degrees from the normal. So this is the 19.8. Okay, guys, good job. Thanks. Text me if you have any questions.